The examples in this section go with lesson 4.7, inverse trigonometric functions. Example 1, find the exact values or state that the expression is undefined. Part A, the inverse sine of the square root of 2 over 2. Using the unit circle, we are looking literally for the angle where the sine is equal to the square root of 2 over 2. So on the unit circle, we want to find every angle where the y-coordinate is positive square root of 2 over 2. And that happens at pi over 4 or 45 degrees, whichever one you choose. And it also happens at 3 pi over 4 or 135 degrees. Part B, the arcsine of -1. Again, we can use the unit circle, and we are literally trying to locate the angle where the sine is equal to -1. So on the unit circle, we're looking for the angle or angles where the y-coordinate is -1. And that just happens once on the unit circle, and that's down at 3 pi over 2 or 270 degrees. Part C, the inverse sine of -3. Now again, we can be looking on the unit circle. We would be looking for the angle where the sine is equal to -3. And there's not an angle on the unit circle where the sine is equal to -3. So what we can do is use the calculator to try and figure that out. And you would be using the second key and the sine key, which will give you the sine -1, and then put in -3. And when you push enter, I think you'll find that you're going to get an error. And that is because this one is undefined. And it is undefined because the range for the sine function is between positive and -1. So anything that's not between positive and -1 is not, we're not going to be able to take the sine of, or the inverse sine of. Example 2, find the exact values. Part A, inverse cosine of -1. Again, using the unit circle, we will be looking for the angle or angles where the cosine is equal to -1. In other words, where the x-coordinate is equal to -1. And that just happens one time, and that is at pi or 180 degrees. Part B, the inverse tangent of -square root of 3 over 3. Again, we're going to be looking on the unit circle. Now let's come over here and do a little bit of scratch work. We know the tangent is defined to be y over x. And so we know we want this to be equal to the -square root of 3 over 3. And so this is actually a fraction that has been rationalized, and so it could be rewritten as 1 divided by the square root of 3. And so we're trying to find the ordered pair where when we divide the y-coordinate by the x-coordinate, we get the fraction -1 over the square root of 3. And I think that's going to be when we have a half divided by the square root of 3 over 2. Because this will turn into a half times 2 over the square root of 3, and then the 2's will cancel, and we'll be left with 1 over the square root of 3, which is what we want. So we are looking for the angle where we've got the square root of 3 over 2 for x and 1/2 for y, and one of these is negative. So we're looking for the angle because the tangent is negative in quadrants 2 and 4. Which means the angles we're looking for are going to be in quadrants 2 and 4, And the coordinates are going to have square root of 3 over 2 for x and 1/2 for y. All right, that's going to be at 5 pi over 6, or 150 degrees. And it's also going to be at 11 pi over 6, or 330 degrees. Part C, the arctan of 0. We will be looking literally for the angle where the tangent is equal to 0. That means we are looking for an angle that has coordinates of 1 and 0. We want 0 to be in the y, because remember the tangent is defined to be y over x. And that's going to happen in 2 positions. It happens at 0 degrees or 0 radians. It also happens at pi, or 180 degrees. Example 3. Use a calculator to approximate the function values in both radians and degrees. Okay, so what I'm going to do is I'm going to have degrees here, and then I'm going to put radians over here. And I am going to set my calculator so that it is in degrees. And the first thing we're going to do is tangent 7.92. Now notice this is not inverse tangent or arctangent. So we're just going to do regular tangent 7.92. And this is giving me 0.1391. Part B is asking for the arc cosine. That's the inverse cosine. So we're going to do second, and then we're going to do cosine, and then we're going to do 2 over 7, and we're in degrees. This gives me 73.3985. All right, and then part C, we have the inverse sine of negative 0.81. So in degrees, we're going to do second sine, negative 0.81. And this is giving me negative 54.0959 degrees. Okay, now I'm going to go in the mode and I'm going to switch my calculator over to radians. And I'm going to do this all over again. And put in the tangent of 7.92. We're in radians. Push enter. And this gives me negative 15.1253. Now let's do the arc cosine. We're going to put in second cosine, 2 divided by 7. Remember, we're in radians. And I get 1.2810. And then the last one, the inverse sine of negative 0.81. So it is second sine, negative 0.81. We're in radians. Enter. And I get negative 0.9442. Example 4. Use a calculator to approximate the degree measure to 1 decimal place, or the radian measure to 4 decimal places, of the angle theta subject to the given conditions. Part A, the sine of theta is negative 3 over 7. 180 degrees is less than theta is less than 270 degrees. All right, we have 2 clues here. We know that the sine is negative, And we know that the angle I want is between 180 and 270, which is going to put it in quadrant 3. If the sine of theta is equal to -3/7, then we can say that the angle I want is the inverse sine of -3/7. And we'll put this in the calculator, and I'll make sure I'm set to degrees, and then I'll do the answer in radians as well. And we'll put in second sine -3 divided by 7. And this is going to give me -25.4. Now, this is not my answer because this is in quadrant 4. And our answer needs to be in quadrant 3. So let's take a look at the picture here. -25.4 is going to be right here. The reference angle for -25.4 is +25.4, because remember our reference angles are always quadrant 1 angles. And that means that the angle that corresponds to this quadrant 4 angle should also have a reference angle of 25.4. And if we put it in quadrant 3 over here, that's going to make this angle right here 25.4. And so we're looking for the measure of that angle from the positive x-axis all the way down to my terminal side right here. That means our angle is going to be 180 degrees because we went this far, and then we're going to go 25.4 degrees more. And this is going to give me 205.4 degrees. Now, this we can turn over into radians if we want to by multiplying by pi over 180, or we can redo this. It's going to give us a messy decimal there, so I guess we can just take this and multiply it by pi over 180. 2 over 5.4 times pi over 180 is going to give us took 4 decimal places, 3.5850. So this is our radian answer right here, and this is our degree answer right here. Part B, the tangent of theta is equal to -8/3, and pi over 2 is less than or equal to theta, which is less than or equal to pi. Okay, our 2 clues, the tangent is negative. That happens in quadrants 2 and 4. And the angle right here, the quadrant right here between pi over 2 and pi, this is quadrant 2. If the tangent of theta is equal to -8/3, then we can say the angle is equal to the inverse tangent of -8/3. And when I put that in my calculator, and again, I'm in degrees, we got second tangent, -8 divided by 3, I'm getting -69.4. Now, again, this is a problem because this angle is in quadrant 4. And our answer has to be in quadrant 2. Let's take a look at it. -69.4 is going to be somewhere down here in quadrant 4. The reference angle here, remember, is positive 69.4. And so we need the corresponding angle over here in quadrant 2 that also has a reference angle of 69.4, which means we're measuring the angle from the positive x-axis to our terminal side here. So we're not going to quite make it to 180 degrees. We're actually going to be 69.4 degrees short. Our angle will be 180 minus 69.4, and that gives me 110.6 degrees. And now if we wanted to change that over into radians, because this is our degree answer here, we can just multiply that by pi over 180. And this is going to give me 1.9303. There's our radian answer. So be sure you pay attention. You can do the inverse sine or the inverse tangent, but you have to pay attention to the answer that your calculator gives you. Because if the answer that you get from the calculator is not in the quadrant where you want to be, you're going to have to use reference angles to figure out where you should be. Example 5. Find the exact values. These are compositions of our trig functions. Part A, we want the cosine of the inverse cosine of -1. We can use our unit circle on this problem because just this part in the middle here is asking me to find the angle where the cosine is equal to -1. That means we want the cosine, let's see, the angle where the cosine is -1 on the unit circle, that happens at pi. And then we're going to solve the problem, the cosine of pi, that's just going to give me -1. And so in this case, these two functions could cancel one another out, and our answer is going to be -1. It's not always going to be that way, though. And it's because of the domains for our inverse functions. For the cosine, the domain is between 0 and pi, which is quadrants 1 and 2. Part B, we want the inverse cosine of the cosine of 4 pi over 3. Now again, we can use the unit circle because 4 pi over 3 is on the unit circle. Working with just the interior here, we're going to do the inverse cosine. All right, 4 pi over 3. The cosine for 4 pi over 3 is going to be -1/2. Now we solve the problem to find the angle where the cosine is -1/2. Remember, I just said that the domain on the inverse cosine function is quadrants 1 and 2, and so the angle in quadrant 2 where the cosine is -1/2 is 2 pi over 3. So in this case, the cosines did not cancel one another out, and it doesn't have to do with the fact that the inverse cosine was outside and the cosine was on the inside. It has to do with the fact that the quadrant of my angle here does not match with the quadrant that can be returned for this one back here.